I'd like to go ahead and introduce our speakers for today. Our first speaker is Dr. Blayne Hartman of Hartman Environmental Geoscience. Blayne is a nationally recognized expert on soil vapor sampling, soil vapor analysis, and vapor intrusion. His organization, Hartman Environmental Geoscience, provides vapor intrusion, soil gas, and analytical expertise. For our state and federal regulators on the call today, I'd like to highlight that Blayne is one of the top vapor intrusion trainers in the industry today. Our company, Land Science, has been fortunate to participate in his 2-day and 1-day training seminars in several states across the U.S. If your state agency needs VI training or a VI refresher, I highly recommend that you contact Blayne for more details. Co-presenting today with Blayne is Dr. Mark Kram of Groundswell Technologies. Dr. Kram is the founder and CTO for Groundswell Technologies, a group specializing in automated cloud-based monitoring and modeling environmental sensor and analytical instrumentation networks. He has over 30 years of experience using environmental assessment techniques and has authored several articles, national standards, and book chapters on the subjects. So that concludes our administrative discussion and our introduction. Now I'm excited to hand it over to Blayne Hartman.
Okay, thank you. And hello to all of you out there. I've looked at some of the sign-ins. We can look at some of your names, and nice to see so many familiar names. So let's go. We have a lot of information to share with you, and we're going to hop right to it. All right, so we're going to talk really two major topics in this presentation. The first one is what's going on in the vapor intrusion world, kind of the hot topics that are being discussed at the vapor intrusion conferences. By the way, one of which will be in Amherst, I think, next week?
This week.
This week. Oh, okay. In Amherst, there's a vapor intrusion session. Then AWMA has a session or a conference in December in Phoenix. And then, of course, there's a San Diego conference every March. So the hot topics being kicked around at these conferences. That's topic number one. And then topic number two, and really the title on the title page, this high resolution automated continuous monitoring. That's what Mark Kram's going to present to you. I'll present topic number one. First, I want to summarize, because I'm asked this question all the time, why is vapor intrusion such a concern? Well, here's why. Because we're worried about this pathway over very long distances. I like to say it's the nets. We have very wide nets, hundreds of feet laterally and vertically. So in other words, it sucks in a lot of potential receptors if you have a contamination source, whether it be a plume or a point source. We're worried about lots of compounds. At least the potential list of compounds is very great. Turns out really, in practicality, it's more 10 or less compounds that most of the vapor intrusion sites are concerned with. But there is a long list, 80 plus, and in some cases we worry about many more compounds than just, say, the 5 or 10 that are most common. The screening levels that we're worried about, in some cases less than a part per billion volume, in some cases less than 0.1 ppbV, so we're worried about parts per trillion. 0.1 ppbV is 100 parts per trillion. We're looking at values that are less than 1 microgram per cubic meter for compounds such as TCE and benzene and some others. So that's also another factor. And then there's lots of different types of receptors. We worry mostly about people, of course, but I've been on a number of job sites where I was worried about animals. We were worried about the eggs of tortoises, the eggs of goony birds. And I've even been on job sites where we're worried about fruit, tomatoes and strawberries of all things. Can these VOCs get partitioned into the fruit and then we ingest them? So when you add up all these four factors, it's put them in a blender and mix it all up. What it means generally is that vapor intrusion is a concern at the vast majority of sites, and the vapor intrusion pathway can then hold up a real estate transaction or a closure, site closure. All right, so let's talk about these hot topics, okay? The topics I said, really the title here shouldn't be regulatory topics. It should be more the hot topics being discussed. And the first bullet of point says getting cold. And what I mean by that is most of the regulatory issues that we've been concerned with for the last few years, they've been around a few years. Number one, the EPA OSWR and OUTS guidances, they came out over 3 years ago now. I think for the most part, people have adjusted to them. Number two, ASTM. They came up with an update to the phase standard. I think that was a couple years ago now, 2 or 3 years ago now. So we're kind of used to that. And then ITRC came out with their PVI guidance. And that was 2 or 3 years ago now. So really, I consider these topics to be kind of cold. I shouldn't even say getting cold. I should say cold. Now, there are some states, however, that are working on revamping their guidances. And the ones that come to mind that I know of are Missouri. They just, in fact, released theirs. I know Washington, state of Washington, and I also know Illinois. Those are 3 states off the top of my head that have either just released or about to release some new state guidances. So the topics really that are being kicked around at the vapor intrusion conferences are these, what I call red hot. Sewers. Are sewers a pathway and should we worry about them? Indicators of VI. Models and attenuation factors, and then, of course, the short-term trichloroethylene exposure. So I'm going to address all 4 of these in this order. Why are we worried about sewers? Well, generally, I look at sewers as just being another indoor air source. It's like potentially having a compound in the room that contains the contaminant you're worried about. That's how I look at it. Now, when are sewers the greatest potential source? Well, when the P-traps, which I show here in the bottom diagram, it's when they dry out. And these P-traps are designed to be wet, and then the water acts like a vapor barrier, as you can see in this photo. If that dries out, then you have an open communication, open conduit from the sewer, which in this case is to the right, to the house, which is going to the left. All right. Now, when might P-traps dry out? Well, they dry out in my house because I have 2 guest rooms. And if I don't have guests for, say, a few months, I live in San Diego. We're very dry in general. Those P-traps will dry out within a couple months. So what we do every couple months, if we've had no guests, we go and run water into the sinks just to make sure that the P-traps stay wet. That's all you have to do is run water. I was on a job site in Missouri where this was the case. It was an old jail. And when they didn't have many prisoners, which is a good thing, they wouldn't use some of the showers. And then the P-traps under the showers would go dry. And then they would have vapors coming in from below. So it's really easy to prevent, in most cases, any sewer gas in the house by just keeping the P-traps wet. But let's say you can't. And let's say you want to sample just to see if the sewer is a potential source. It's very easy to sample sewers. So one thing you can do, if indeed you have the health and safety permission to do this, is you can go up on the roof and you can run tubing right down into the roof vent. Just pay it out like a fish line, collect a sample in a canister, a syringe. Very easy to do that. Most structures have cleanouts somewhere between the main out in the street and between the receptor, between the structure. If there's a cleanout, very easy to open that up and run tubing down the cleanout, collect a sample, analyze it. The last thing that one can do is you can go under the sink and drill a very tiny hole, like an 1/8 inch OD or 1/4 inch OD, stick a little tubing through the hole and collect sewer gas that's basically underneath the sink on the one side of the P-trap. And then you just plug the hole up with a little bit of epoxy. So very simple to do, and that's what I'm trying to, the main point here is that sewers, you shouldn't get wigged out about sewers because it's easy to prevent it and easy to sample it. Really, the bigger source of contamination from sewers are going to be from the laterals that run from the street to the house and tree roots perhaps breaking through them, or if they're very old, they'll crack. So sewer gas is more likely to be a source to the soil gas than it is to the indoor air. All right, VI indicators. Can we use some easy to measure variable to predict when vapor intrusion is occurring? Well, what do we mean by that? Well, what about something like wind speed? If the wind speed's high, should we go measure? Or barometric pressure or temperature changes? Now, EPA has really been concerned about this. The last 2 sessions or the conferences that they held in March in San Diego, 2017, 2018, they had a number of talks relating to this. Mark will show you some data after I'm done showing some of the correlations we are seeing with some of these parameters as we do more and more sites. we'll have a better feel for whether there is a VI indicator. But the question I always pose to people is, do I really want to go out and only sample when VI is at its maximum level? Aren't we supposed to really, for these risk assessments, be worried about nominal conditions? Why would you want to go out, and what service are you doing to your client if you're only sampling during a worst case when VI is turned on? So that's something you need to think about. Modeling. In most states, modeling is getting the boot. And so what they want, what the EPA wants, and what the states are leaning towards is, instead of allowing people to model their way out, instead to use the Vapor Intrusion Screening Level Calculator. That's the VISL, Vapor Intrusion Screening Level Calculator, okay? And that's probably what many of you are seeing from some of the states you're working with. Notice California on the left. I've listed some of the states I know have done this. In other words, pushed you to the VISL. I put a double question mark for California. So if any of you are listening from California, the agencies here, we've been waiting for California. A year ago, they said they were going to come out with some new standards, and that modeling would basically be getting the boot. It's been a year we've been waiting, and they've gone back and forth wishy-washy. So we're still waiting to hear what California's going to do on this. All right, now to further complicate things, EPA, after this push to go to the VISL, they pulled down the JE spreadsheets, the old spreadsheets off of their website. Well, lo and behold, back in September 2017, about a year ago now, all of a sudden, they post new versions of the JE model. So I jokingly said, well, this is the return of the JE model. They released it again. They posted it on their website. I didn't check before today to see if it's still there, these new versions. My guess is it still is. If you go to that model and you download it and go to the README page, which is where you're supposed to start, it says, quote, the JE model does not replace the EPA VISLs. Initial site screening, please use the VISL, which of course is very, very conservative. It doesn't make clear then that if you indeed fail the VISL, in other words, you have a potential vapor intrusion problem, can you then go and use this model? It's not made very clear. Just for grins, I went and did a quick model run to compare it to the VISL. Trichloroethylene, subslab, soil gas, 1 in a million risk, and you can see for residential receptor, 82 if you use the model, 16 for the VISL, 5 times less restrictive, and for commercial, 350 versus 100, 3.5 times. Now, the other thing I'll tell you about this new model or new XL version they released, the person that wrote it apparently, I've heard, is no longer with EPA, and the technical support person is no longer with EPA. So as I understand it, and if anyone from EPA is listening and I'm incorrect, let me know. As I understand it, there's no technical support available for this model anymore. So I say, can we make this more confusing? You say use the VISL, but then you go post new models, then you don't have technical support for it. So as you can see, it's kind of a mess. All right, so now let's go back to what the VISL uses, and that's a default soil gas attenuation factor of 0.03 for both soil gas and for subslab data. So what we have here then is the source of this 0.03. Where did it come from? Well, I list that for you. The source of the data is this white paper put out by EPA in March 2012. So I listed there. That's the title. The only thing I did to the title was I bold-faced and turned in red and underlined the word residential. And what we have is a plot of indoor air versus subslab from residential structures. And you can see that there's a lot of scatter in this correlation, and that's the key to keep in mind. A lot of scatter. If one did a regression analysis on this, it would not have a very high regression coefficient. So keep that in mind. But this is where it came from, the 0.03. The 0.03 is the 95th percentile of that data set. All right, so it raises the question then, should we be using 0.03? So there again, there's that title. I just repeated it for you in bigger text. Once again, residential in red. And here's what the conclusions from this report, this is EPA's report, taken right out of the conclusion section. The attenuation factor recommended for residents with basements, 95th percentile, 0.03. There's the 0.03. But with subslab structures, it's 0.01. So why are we using 0.03 for all structures? Should be using 0.01, seems to me, based on that report. So why has everyone jumped to 0.03? The other thing is, now I'm going to show you, remember this is residential in red. So now what I'm going to show you is that same plot of indoor air versus subslab for commercial structures. And there it is. No, there's not an error there. There's the database. There are no data. There is no database for commercial structures. And so EPA is saying, and the states are saying, well, use the 0.03 since we don't know what else to use. There's absolutely no data to support the use of 0.03. What do I do when I'm doing commercial structures? I measure radon underneath the structure and inside the structure to determine a structure-specific or slab-specific attenuation factor, because using 0.03 has no technical basis at all. All right, so that's the models and attenuation factor issue. Back to the hottest topic, next to PFAS, that is, short-term trichloroethylene exposure. I'm going to assume all of you listening have some idea what it is, but to say it very quickly, we're worried about the malformation of hearts in pregnant women during the first, I think it's the first trimester of pregnancy, so hence the pregnant woman, hence the bandaged heart. Now, all of this concern was raised by a study done by Paula Johnson, not Paul Johnson, in 2003. Now, they observed these fetal heart malformations in the first trimester of a rat, but it was based on oral exposure, not inhalation. They fed the rats basically water that had been spiked with TCE. So that raises one question, is the partitioning of TCE into the human body going to be the same if you drink it versus if you breathe it? And this study has been done previously, previous to Johnson et al., and then after Johnson et al. There's 5 other rodent-rabbit inhalation studies, and there wasn't any fetal heart malformation in any of them. So the Johnson et al. Study seems to stand out against the other 5 studies, including one that was done after her study. Well, the solvent industry said, you know what? There's a lot of other errors, by the way, and potential errors in that Johnson study. So the solvent industry said, let's try to reproduce Johnson's study. And they've tried this now 2 or 3 times. The most recent trial or study was actually successful. It concluded 2 months ago, August 2018. That's a mistake for those who are looking at this slide. August 2018, it was concluded. The evaluation of the data is currently in progress, and we expect to hear the results by the end of 2018. Be very interesting, everybody, if this study shows no fetal heart malformation. Be very interesting to see what happens and what EPA does. Stay tuned for this one. Could get very interesting. Meanwhile, while we're waiting for the results of that study and, of course, the debate that will continue from it, meanwhile, we've had different regions come out with different standards. In fact, most of them have. I grabbed the Region 7 standard because it was kind of one of the more recent ones a couple of years ago, and it was one that was a little bit specific in terms of how they are viewing the short-term TCE issue. This is their text and quote. It is assumed an exposure to TCE at any time during. Now, I'm the one that turned that text to red with the underline. At any time during. So they're not saying that you need to be exposed for the full trimester, 21 days. They're saying at any time. And then they say, okay, so for a residential situation, we're worried about a 24-hour exposure period of 2 micrograms per cubic meter. For a commercial, 8-hour exposure of 6. Now, if you multiply 2 times 24 or 6 times 8, you come up with the same thing, 48 micrograms essentially of exposure. So the text says at any time. So this raises the question then that if 48 micrograms is the key amount of mass that you can be exposed to, what happens if I'm exposed to 48 micrograms per cubic meter for just an hour? What happens if 96 for 30 minutes? And you see, we can just carry this forward. 480 for 6 minutes. Well, obviously, this it's a different toxicology situation here. And when I asked this question to toxicologists, does this carry through like this? Essentially, is it linear? I don't get a consistent answer from the toxicologist I talked to. All right, well, with all this going on, many states have been reopening TCE sites. So here's just a partial list of the ones I know of. If you're a state regulator and you know you've reopened sites or are going to, please let me know so I can add to this list. So they're jumping on the bandwagon, so to speak. And what does this all mean? Well, we don't have audio, so you probably won't hear this, but it means money. All right. So that's kind of the summary of the hot topics. So now what I want to say to you before I pass the baton to Mark is I've been doing vapor intrusion assessments since the mid-90s, so over 20 years now. And in my mind, the fundamental problem with vapor intrusion assessments and trying to figure out vapor intrusion remedies is not enough data. So when you use canisters or passive collectors, these types of things, here's what you get. You get a data point averaged over some period of time, 8 hours, 24 hours, 21 days, something like that, right? So let's say that there's our screening level and this data point is just above the screening level. So what do? Well, it's just above. You're going to go back and do it again. In fact, most agencies now want a second sampling even if you were below the screening level. So 6 months later, you go back and what do you get? Oops, now we're below. Now what do? Well, most likely, you're going to be going back a third time to see if it's above or below and a third time. And now you go back and you get this. And now what do? And so maybe 6 to 12 months have passed and you're still in a quandary as to what to do. So to me, if we had more data in between these time gaps, we'd have a much better picture of what's going on. Well, we now have that ability to gain that data, that type of data, and that's what Mark is going to pick up and talk to you about now.
Excellent. So I'll talk a bit about the technology. I'll present some data from a couple of these sites that were specifically selected to articulate a couple of lessons that we've been learning, and then we'll open it up to questions there. So here is one of the configurations that we've been using. Many of you will recognize this laboratory grade instrument, a gas chromatograph that we've customized in a way that allows us to monitor for multiple locations over time in a continuous monitoring mode. It has a PC connected to that so that we can have data flowing both forward and backwards, if you will. So remotely we can actually control the instrument, but as soon as we determine a concentration, it gets sent to the cloud where it's automatically processed and made available. The system is fully quantitative. It's not laboratory, or it's not screening level. It's actually laboratory grade instrument, and it's very sensitive. So additional modifications have been applied to this to allow us to meet these ultra low levels for a lot of volatile organic constituents, trichloroethylene, tetra, and even vinyl chloride and others. Very quick analytical time. Each routine takes a little bit less than 10 minutes. So if you have 6 sample locations, every hour it will come back to that first location. And we can monitor from multiple locations, typically up to 16, but we can also modify it to go up to 30 locations at a site. It's essentially a modified EPA method TO14A. We've had this out for up to 11 months without requiring recalibration. And we can remotely control, so we can not only change the routine and change the locations remotely, but we can also have other types of things that we can engage along the way. The data is uploaded real time, and we have alerting and even controlling components to it. And perhaps one of the most powerful components and capabilities is the fact that we can switch from continuous monitoring mode to discrete mode. And this is a key for answering questions. So for instance, you get a big hit somewhere in the facility, you can go and explore that with a syringe, and then 10 minutes later, you can answer the question, did somebody bring something in, or is that really a VI intrusion location? We've been using continuous monitoring for confirming, mitigation, optimizing, and also for protecting occupants. We have been experiencing situations where dynamics were observed with HVAC modification, fans, air filtration. We've come in after people have sealed cracks and sumps. We've helped people optimize SSD systems, and then I'll talk about a couple other building manipulations that are very simple but give us a lot of insight regarding where issues might occur. On the remediation side, we've been working on several sites, mostly thermal, but we're also starting to get into areas where, for instance, methane buildup with in situ chemical reduction have occurred. And we can control those emissions quickly because we can detect when breakthrough occurs, and then the field personnel can actually respond to that without having to wait for a laboratory result. In terms of deployment, it's fairly straightforward. You just need a table. I'll show you some pictures of this. We can put it in a trailer, we could put it in a room. We have sample lines that can run up to 300 meters from the instrument. In terms of O&M, very simple. We just need to have access to power, and every several months or so, if you go for long durations, we can change out the carrier gas. We do need internet connectivity, so if the facility doesn't include that, we can bring a pack to have set up a system right there. Here's one image of one of the deployments. This was in a trailer, so you can see where the system is connected to a valve controller, and that runs to the lines that will run to the monitoring locations. Here is an image where people are deploying some of the sampling lines. So the gentleman will run that to the area that we want to monitor, and he'll run the other end of that tube back to the instrument itself. In terms of data, we'll track concentrations, pressure differential, climatic data, and then it'll be presented in an intuitive manner. We can look at time series, stacked series, contour images, moving averages, and then we can also not only trigger alerts, but then document when and where those exceedances have occurred. And then if you'd like, we can also trigger relays and turn on blowers, things like that. It's all web-based, so you don't have to download any software. We'll just give you a password, and you can sign up for reports as well. Here's one configuration of the dashboard where you can see in the upper left the data channel. In this case, we're looking at trichloroethylene at a specific time step, and then we have moving averages as well. This is a provisional contour image. It's not spatial statistics, but all that data is available, so you can do kriging and other types of things, or model calibration, etc. Then you have moving averages. There's a pull-down menu, so you can change the duration over which you'll run that average. And then you can track time series for any of these locations, or even a moving average for the whole swath of monitoring locations. And then in the lower right, we're tracking when an exceedance occurred, what that value was, and where it was coming from. Stacked time series is extremely helpful. It's really helping us articulate cause and effect. In this case, this example, you see barometric pressure on the top, TCE in the middle, and wind speed. So this gets into some of those indicators that the EPA has been very excited about. Again, we can set up rules for thresholds for triggering an alert to the key personnel, or even turning on blowers. Okay, let's get into some data. So we were trying to explain the power of this to a regulator on the East Coast, and they said, okay, you guys think you're you know, hot stuff. Why don't you come out here, because we have a Freon issue in this building that we've been monitoring. And they had passive time integrated data leading up to this, and they couldn't figure out why they were seeing Freon in these samples. Well, this is 24 hours of monitoring in this one building, and this is after 2 days. So immediately, I'm sure the majority of the people on this line will immediately see that, you know, this is some kind of pattern. It looks almost like a heartbeat, if you will. It turns out that the HVAC system needed to be modified because it was drawing in the Freon. And they were able to see this because they had that signature here. We actually monitored for 10 days, but what's beautiful is you could start modifying the HVAC and watch and see how that impacts the chemistry indoors. Here's another beautiful example. This was a federal building where they had been scratching their head about where vapors might be intruding into this building. So Blayne was walking around and taking samples in a discrete mode, came across a room that had a drain in it and started getting hits of concern for trichloroethylene. It was getting close to quitting time, so he had this great idea. He said, you know what, I'm going to set this on continuous monitoring mode. I'm going to close the door and I'm going to go home tonight, go to my hotel, and tomorrow morning I'll come back and we'll see what happens. And sure enough, you can see this beautiful rise in concentration over time. When the consultant returned the next morning and opened that door, you saw an immediate drop in concentration. And then once they closed the door again, you saw it start to rise again. Well, this confirmed to us that that was a point where vapors were coming into the subsurface or into the building. That pattern was a key. Imagine what kind of data you would have gotten with a passive time integrated sampler. You might not have been able to figure it out. In fact, before we were out there, those types of samples were collected. But the beauty of this is that we can find those VOC entry points right away. That pattern that we saw is related to the mass flux. So for those of you that are excited about evaluating those types of considerations, this data would be very helpful for that. But also, it was very simple building manipulation that helped us answer that question. Closing the door, that was easy. And they know exactly what to do, the next step, seal that drain and start extracting. Here's a similar situation at another facility on the East Coast where the spatial pattern was revealing right away that we had some kind of issue in a basement where there were 2 sumps. So after watching it for a while, the consultant got a very smart idea. He said, let's cover these sumps and see what happens. So he went to the hardware store and got, you know, very low cost materials. And sure enough, as soon as those were covered, we saw an immediate drop in concentration. So they confirmed that that was where materials were coming into the building. Once again, that pattern was key. We saw a temporal variation and we saw a pattern, but we were able to instantly, with just an easy building manipulation, easy to confirm that those sumps were the culprit, if you will. And you can see an image below there. All they did was covered it with Visqueen and some pipe and some sandbags, and then we immediately saw, without having to wait for a lab result, a response. So to pause for a second, we're seeing these patterns right away, within days typically, sometimes even quicker. But we can quickly determine if it's from vapor intrusion or if there's an indoor source. And therefore, we can determine the cause and effect. We can also do time integrated averages and figure out how often you're above the screening level, or whether you've exceeded certain thresholds for toxicological purposes. And probably most importantly, we're resolving these questions with a single mobilization. Again, that pattern is that opportunity. Okay, here's another fascinating lesson that we learned. We were in San Diego at a large federal facility, and you can see in the lower left-hand corner, there's a time series chart. And we had some very large hits. in the hundreds of microgram per cubic meter for TCE. And they were occurring consistently at around the same time every day. Now, I lived in San Diego for a while, and I remember that in the midday you see the sea breeze starts, and that's because of pressure changes. And so we started to look at what was happening in the nearby airport right across the bay. And the gray line here in this top chart is barometric pressure. The blue represents the concentrations that we were reading for TCE. And you can see some of these are almost 400 microgram per cubic meter. They actually exceeded at one point. But every time there was a drop in barometric pressure at the land surface, that's when we got a hit. And so the consultant was very clever, deployed some pressure differential sensors, and you can see along the base or along the second chart there below that every time you had a positive pressure differential, meaning that the subsurface was a higher pressure than indoors, the Earth basically exhaled. And that coincided with this pressure drop at the surface. And this is a beautiful pattern that we're starting to see at many different facilities. But the beauty of this is it's saying that we can solve this now because we understand what's causing this. This daily fluctuation, this diurnal change, basically results in a slight pressure differential. It doesn't even have to be that large, and that's what's causing the vapors to flow in. We have a reference there, a citation, if anybody's interested in that paper. At that same facility, consultants designed a very innovative vapor extraction system, and we were called back to evaluate and confirm that it was working. And you can see by these charts between the pre-SVE and the post installation of the soil vapor extraction system that it dropped down dramatically, and we were able to confirm that it remained at low levels there. So again, that pattern helped us observe large variations, and we saw that there were pulses of these peaks, if you will. Those highs correlated with these pressure dynamics, and the correlation between differential pressure and concentration was evident. A lot of the state guidance that I've read suggests that when you collect a sample, you document what the barometric pressure is at that time. I submit to you that while that could be helpful, it's not as useful as the pressure trend, because if it's increasing, you'll probably underestimate the worst case. If it's decreasing, you'll probably hit that peak. But bottom line is that the pressure differential will help you a lot in that regard. We confirmed that that vapor extraction system was working as well. So after observing that, Cliff decided to build a couple of systems that would integrate really well with our platform so that we can use it in a stacked time series configuration. So we've got a wireless system now that we deploy. In some cases, we've used up to 10 of these at a specific, at an individual facility. But it'll send it to our base station, and we can couple it with chemical data. We can also use this as criteria for engaging controls. Here's a site. A large firm was having a VI issue, and they needed to design and optimize a subslab depressurization system. So not only were they looking at pressure differential, but here they're looking at chemistry, at TCE concentrations from multiple locations. And you can see as soon as they engaged that system, we got an immediate drop off of the concentration. So that was a really nice way to show the regulators that this was working. This is from a thermal remediation site, a Superfund site located in the San Francisco Bay Area. And we're tracking from 13 locations, and one of them was a warehouse. And as soon as that system was energized, we started to see an increase in trichloroethylene in that warehouse. Also, on the effluent side for the treatment, we were able to see breakthrough of vinyl chloride on the treatment side of that system. But we were able to immediately respond because we were able to detect that without having to wait for a laboratory result. So that adaptive response that resulted ended up allowing the folks in the field to make modifications on the fly and watch the results. And so you can see that we saw the concentrations in that warehouse drop off to safe levels. So we learned a lot of lessons with that project. This was actually the first time vinyl chloride was ever monitored continuously. But we got instant recognition of breakthrough. So folks were able to adjust and optimize the system. We were actually running calibration runs every cycle, and we were triggering these alerts and getting folks out there that were in the know. We monitored for 11 consecutive months. This was so far the longest that we've monitored for. We integrated it with EPA Viper. It was a Superfund site, so now that capability exists. But the key is that continuous monitoring allowed the folks to immediately respond and prevent exposures and liabilities without having to wait for a laboratory result. Okay, I've got a couple other quick examples here. This one I love. This was a furniture manufacturing facility. And again, it was a mystery site. We've been called in to help with a lot of these mysteries, if you will, where some data was collected, but they really didn't understand all the nuances. This building was for sale, and the owner had an offer from somebody that was lowballing them by about $2 million less than the asking price. The reason being is because previous investigations suggested that there was a vapor intrusion issue. They had subsurface TCE and PCE. So we started monitoring in the late afternoon, early evening, and we didn't see much. And then sure enough, as soon as people started to work, we saw these peaks, and it would drop off later in the day when people stopped working. We were only seeing the TCE increase during working hours, and these are high hits, over 200 microgram per cubic meter. The pattern was all throughout the facility, so it had to be something that was going on indoors. So Blayne and the consultant was walking through, they were walking through the facility, and they saw people using this silicone spray to lubricate some of the machines. Now, if you look at the back of these on the labels, TCE was not mentioned at all. But Blayne got a great idea. He said, you know, I've got the GC right here. Let's evaluate some of these materials. And sure enough, we look at the chromatogram of the silicone spray, and we get a significant TCE hit. So that was wonderful. They got rid of that, and we saw the concentrations drop off immediately. Again, what did we learn? We were able to help the consultant conclude, and the regulator, that there was no vapor intrusion using multiple lines of evidence. We resolved these mysteries. And this was very quick, within a couple of days, that we were able to accurately source that indoor source, if you will. We protected the occupants. That was obviously very important. And of importance to the owner, he was able to get full asking price after that. So we saved him $2 million with just about 3 or 4 field days of effort. Okay, here's my last example. And this is a recent dry cleaner that we worked at. In this case, the stacked time series were used to convey a very important message here. So we have 5 different monitoring locations in the dry cleaning facility, and the consultant was very, very clever. What they did was they annotated this to show that the maximum concentrations were only occurring when the building was not occupied. During business hours, when the building was occupied, concentrations were always at safe levels. And that was primarily because they had the business, when it operates, the front door is open and there's a back door that's open as well. So there's a breeze flowing through the facility. And here's another way that they've actually shown that. So they took the data and generated 8-hour time-weighted averages for both the worst case as well as the worst case during an actual work shift, if you will. So in the top chart, you see during the evening, when after business hours and in the early morning, this is when you got the worst case, and the system generated a time-weighted average of 1.54. The highest hit was at about 2.6 or so. But during the shift, during the working shift, The only hit that they got was in the early morning, right as they were opening up, and then the rest of the day, it was very low, and the time-weighted average for 8 hours was 0.27. So we learned a lot. The concentration pattern is essential for this type of interpretation. We determine those, not only the exposure levels, but also those durations, and we could compare the work and occupancy schedules. We were able to demonstrate no risk during the work, and they're getting closure of that site right now. They've been notified by the regulator that they're satisfied with this effort. Okay, so I'll wrap this up really quickly. So we're not the only continuous monitoring tool out there, but we've been learning a lot with our system, and I highly recommend that people consider this to try to resolve some of these concerns. We can play a role in many different phases of the investigation and mitigation and remediation, et cetera. But we can monitor, respond, and confirm. We're seeing a lot of analytes of concern, including methane as well as these other VOCs of concern. And I keep hammering this home, the pattern is that opportunity. It's the opportunity to move from this endless do loop of monitoring and repeating to the next phase, so you know what to do next. We can rapidly address the following in a single mobilization. We can quickly determine that there's no risk. If there is an exceedance, we can identify whether or not that is an indoor source, or if it's really VI, we can identify where it's coming through the slab and these preferential pathways. We can evaluate and optimize mitigation and remediation systems, and we can do these types of things very quickly during escrow. So for real property transactions and brownfield concerns, we can help meet those very effectively within a couple of days of field effort. And perhaps most importantly, until things change on the regulatory realm with TCE, provided they do change, at least for now, we can prevent those acute TCE exposures. So there are a couple quick questions I'll kick this off with, and then I'll open it up, or Rick can open it up. What does it cost? Typically, it's about $1,000 to $2,000 per day. The rate depends on the duration. It's lower cost for longer duration. So it's about $10 to $15 per analysis. You get about 140 per day plus. If you consider that you're going to go to 10 locations that you want to monitor and 10 canisters, we're looking at about $5K already, right? But it can be higher with reporting depending on the complexity. But consider the value. You're going to the next step. You're not going to have to go back there and repeat it typically. What do the agencies think about this? We've worked with many of the EPA regions, with many of the states, and we've got several upcoming projects where we're going to add to this list. We've worked with Department of Defense. We're going to soon be working with the Army Corps, and we've been starting to work on international scale as well. How do these results compare to the TO15 that we're all used to? We've yet to receive a complaint. So a lot of these projects, since we're still relatively new, even though we've been doing this for about 3 years, folks want to be sure and then collect a SUMA canister. But to date, we haven't had any complaints. And with that, I want to again thank Rick and his colleagues at Land Science and REGENESIS for this opportunity, and I want to thank you for your interest in our efforts. And we're available now for questions.
Perfect. Thanks, Mark. Thanks, Blayne. You are correct. We're getting into our Q&A process. We have about 7 minutes to get through that. Just want to remind you, you will be receiving a survey. Please, please, please fill it out. We appreciate that. And then after the webinar, you'll be receiving a link to the recording. So with that, I'm going to go ahead and just jump into the Q&A. For those of you, if you're not sure how to submit a question, on the right-hand side in the menu of GoToWebinar, there is a section called Questions. You can submit that question. Only the panelists will see them, so there's no risk of asking a dumb question. And so please get those in. We've got a number, and if we don't get through all of them in this period, we will respond to you directly. All right. So there's a specific question for Mark on the furniture facility with the daytime TCE increases. Were you able to determine why TCE was not listed in the products that were the source for that material?
That's a great question. We were not able to do that, and it's probably a good thing I'm not an attorney. You know, that's not the first time that we've seen something like that. In fact, we were at a site recently where we evaluated some spray that was used in a bathroom. It was a disinfectant, and it did not have TCE. All it said on the MSDS was, you know, 40% quote unquote other products, other materials. So if there's a question about it, we can quickly analyze that, but it's a great question. We weren't able to resolve why it wasn't listed.
Okay.
And can I add to that?
Sure.
This is Blayne. We've been finding a lot of products that you would not think contain TCE or PERC for that matter, and yet we find out that they contain those compounds. So for example, one that tripped us up on one site that we discovered was coil spray for cleaning air conditioner coils. And I could go on, we're short on time. So there's a lot more products with trichloroethylene out there than you would be very surprised at how many are out there.
Here's a specific question related to the contaminants. Things like 1,1-DCE, you mentioned there's 80 plus. Can you kind of get into some of the more elegant contaminants? Are there any limits? What all can you look for with the continuous monitoring system?
Well, vinyl chloride is one that's, I'll say elegant because it was a little hard to do, but we were able to do it. Carbon tet for people that are dealing with grain silo sites, chloroform. We're now talking about doing a site with dichloropropane. Then there's another one that's marked in my dichlorobromo propane, DCPE, something like that. So yep. What happens is that we get a request from a client that'll say, can you do this compound? And generally I'll say, I'm not sure. And so what I'll do then is I'll order a standard from a supplier and I'll give it a test to see if I can go that low. Another one was chlorobenzene, for example. So if it's a VOC and it's not one we've already done, then we test to see if we can do it and reach the levels of concern.
Okay. Another question related to continuous monitoring. Have you ever used a system to measure flux chambers from soil gas?
Yes, we have. And for brownfield sites, by the way, the application there is to take an open field that doesn't have a structure, create some type of structure, and the simplest way to do that is to put down, some type of big plastic sheath, as you saw in that one picture, and then monitor what's underneath that structure, the plastic sheath, or it can be a small little building that's put there for that matter, a temporary building. So yes, the answer is we have.
Okay. So here's a question for Blayne, based on the first portion of the webinar. You spoke about the Johnson Editor spreadsheets. Can you comment on the EPA's online calculator tool?
The VISL, Vapor Intrusion Screening Level Calculator, the Excel version that you used to download, I did not like at all. I found it clunky. But the online calculator, that one is actually very easy to use and very flexible. You can actually change attenuation factors. So if you go out, for example, and measure the attenuation factor using radon at a commercial building, you can then go to the VISL and plug in that attenuation factor over the default to 0.03. So the online VISL is actually very, very good.
Okay. So Mark, here's a kind of simple question related to the pressure differential, asking about what sensors you use to measure that.
So we go to a supplier that builds things for HVAC types of systems, and we had Cliff integrate this with a circuit board that he built, and so essentially what we're able to do is we have, if you've got, say, a vapor pin or something like that, we'll connect to that so that we're actually feeling the pressure under the slab. And it's not a calculation, it's actually a measurement between that pressure and an open-ended part of that sensor to the surface indoors. I'm not sure if that answers the question, but if you have other questions related to that, or you want to try one of these systems, we'd be happy to comply.
Okay. Here's a fun one. Has this continuous data been tested in court? Meaning, have you used this analysis in a court proceeding?
I have not had anyone tell me that they have done that. I have not had any lawyer subpoena us. So I don't know.
No, I haven't either. What we have done, though, is while people were negotiating with cases that were ongoing, they had us go out there and do some tests. But we weren't privy. We weren't the experts on those cases, so we don't know if they use that data.
Okay. Here's a practical question related to the deployment. Is this something that a VaporSafe representative does, or technicians from the consulting firm? What all goes into the install? And
we can do it both ways. Generally, we want to know who the consultant is and have worked with them at least one time with us present, so that they can kind of see how the setup goes. And then if indeed they seem to have a grasp of it, we can ship them the instrument and let them set it up. So yes, we've done it both ways. Generally, we can let the client repack the instrument, even if they've never used it before, so they can save on demobilization costs. We don't have to go back to the site. They can pack it up and ship it out and save the client money.
Okay. I'm looking at the clock, Dane. Where are we at on timing?
12:01.
Okay. So maybe a couple more. We've got a ton of questions, and if we didn't get to yours, we will respond. I have a question, and I'm going to kind of generalize. It gets to folks wanting to know if this has been done in, say, other countries like Canada, New Jersey, any states that you want to highlight where this technique has been utilized.
Okay, we just set up a system that in Australia. It'll go on its first job next week, and it will remain there permanently. So we actually have a person that has championed this throughout Australia, and they have a lot of TCE problems down there. We will be starting a job in Belgium sometime in November, it looks like. And then we are having discussions with a group in Israel about a large site in Israel. So the nice thing about this gas chromatograph, it's small enough and robust enough that it can fly around the country and also fly to other international locations.
Perfect. Well, great. Well, all good things must come to an end. That will be the end of our Q&A period. Like I said, if we didn't get to your specific question, we will follow up with you directly. For more information about Dr. Hartman's vapor intrusion services, you can visit hartmaneg.com. Same with Mark Kram and Groundswell. Please visit groundswelltech.com. If you need immediate assistance with vapor intrusion mitigation, we would love for you to contact us at Land Science. You can reach us at landsciencetech.com. Thanks again to Blayne, Mark Kram, and our whole team here. And we wish you a very nice rest of your day.
Thank you.